Alrighty, so we are about 3 minutes after the hour. I wanted to just get going with the presentation. Thank you so much, everyone, for attending today. You are attending the second out of a series of 3 webinars that DataKind is presenting on our work with Omidyar Network investees on the extractives industry. You're listening right now. Who's speaking is Erin Akred. I'm a data science manager at DataKind, and I'm leading the learning and synthesis portion of our projects with the Omidyar Network. I'm going to start by addressing a couple of logistics in this presentation. I'll be leaving a few opportunities to ask questions. You may have noticed that you don't have microphone access. We'll be using the Q&A functionality in Zoom today to surface your question. So as they come up, feel free to enter your questions for me on the project team there, and we'll address them throughout the presentation. Now, without further ado, a recent partnership between DataKind and Omidyar Network began with scoping 2 projects with Omidyar Network investees from the Columbia Center on Sustainable Investment, Global Witness, Natural Resource Governance Institute, Open Oil, Publish What You Pay, and the Transparency and Accountability Initiative. We came together as a group back in August to discuss the scoping phase of these projects, and you can listen to the recording following the link from DataKind's blog. We talked about the 6 components for a successful data science for good projects, and how it takes a village to leverage advanced technology for good. The 2 projects are now currently in the execution phase of work, and we have brought you together today to share learnings from the exploratory and prototyping solution phases of doing data science projects in the extractives industry. Our hope is at the end of this engagement together, Omidyar Network grantees and other social actors will operate more efficiently and effectively to combat government and industry corruption, learning what they have in this series of webinars. So today, we'll first talk generally about the exploration and prototyping solution phases of any DataKind project. Then, for those new to these webinars, we'll briefly reintroduce the 2 projects, then describe how they have been progressing through the execution phase. Finally, we'll reflect on the execution phase with a few takeaways. So, the exploration phase is the first meaty phase of any DataKind or data science project. The big goal of this section is to understand an in-depth knowledge of both the data and the partner organizations that the data science is done on behalf of. Having kicked off the projects over the summer, the team's first focus was on exploring the data, problem, and partner organization. In both our cases today, our analysis leveraged mostly open and in some cases proprietary data to develop solutions. But as we discussed in the previous webinar, there was a fair amount of effort involved in finding problems that would help advance the mission of our partner organizations. So, the exploration phase was largely about understanding what the data could and could not do and how to pivot our efforts to be able to deliver the greatest insights possible. One challenge that has arisen is cloud cover and satellite imagery data. You'll hear a little bit more about this project later, but I just wanted to mention that the team is working on mitigation strategies as well as other challenges around image resolution. And this is very typical of the exploration phase of a DataKind or other data science project. In the contract project, contract metadata enrichment, we were granted access to certain data, but this was likely not going to be sufficient to do our modeling. So the team sourced additional data to beef up our original data set. And this is, again, very typical of what happens in the exploration phase. We'll try to understand what's available to us, what we would potentially be able to do with the data, how closely that matches the scoped problem statement, and then further, where can we go from here? So that's really what the exploration phase is about. It typically lasts approximately 6 weeks. And then there's the prototyping solution phase. This is, again, approximately a 6-week phase, and this is where the teams work to be able to present draft model findings for feedback from the partner organizations. So prototyping solutions, we'll go through a couple slides on the specific two projects we're talking about today. But these are the main tasks that the teams will accomplish in the exploration and prototyping solutions phases. Now about the specific projects. So the first project is on contract metadata enrichment. And the background for that project is that those working in the extractive industry governance aim to help local communities benefit from their country's endowments of oil, gas, and minerals. One of the ways they do this is by assessing 100+ page extractive industry legal contracts for things like fiscal governance, environmental reparations, but this is a time-consuming, manual, and subjective process, usually performed by legal experts. Automatic generation of metadata and annotations would allow those reviewing the contracts, including those without legal training, to quickly find relevant contracts and clauses within those contracts in order to focus on what is different about one contract compared to a standard, and make their assessment based on a high-level analysis of metadata as opposed to extensive word-for-word comparative review. I'll shout out that in this project we scoped with several of the Omidyar Network grantees, but we are working with Natural Resources Governance Institute, an organization who does a lot of this contract review and has been pivotal in the effort to get the data up online and make it open data. So within this contract metadata enrichment project, we have two main focuses. The first is on finding clauses, and what I'm showing here on the left-hand side is an example of a snippet from a contract where someone has annotated where there are royalties clauses. So this share of the government share shall be excise tax on mineral products. This is someone manually saying this section is about royalties. If you're interested in royalties, look here. And there's some good navigation on the resourcecontracts.org site to navigate to those types of clauses. There's another challenge that exists around reviewing the contracts, and that's finding templates and finding differences from the templates. And so when you one goes on resourcecontract.org, you'll get a listing like what's shown on the right here. These are all contracts from the Philippines, from a range of different years, for a number of different sources. And what we would like to do is say, okay, for example, this Greenstone Resources contract, how does that differ, if that's not the template for the Philippines, how does that differ from the template, and what stands out about that contract and in what way? So those are the two tasks that we're really trying to focus on in the metadata enrichment section. We're leveraging publicly available extractive industry contracts to extract data using natural language processing techniques to train a suite of machine learning models which will assist legal reviewers, journalists, regulators, and community activists by identifying the things like I described: royalties clauses, stabilization clauses, and where a contract differs from a template. The data for this project is represented on this slide. Our first source of data was this 1,510 documents on the resourcescontracts.org site. NRGI, with a number of other investees, as you can see on the listed below, have spent a significant amount of effort getting some of these contracts up online, these 1,500 contracts. They also had a backlog of 474 contracts. So initially we were thinking about doing the project with the 1,510 contracts, and then we thought that given that this is a natural language processing task and classification, we wanted to beef up that input data as much as possible. So we pulled the backlog of contracts, another 474. We also found the site Open Land Contracts, which is also in part supported by NRGI, where there's another 193 contracts that fit generally the same type of format. So we added those to our contracts, and we have a total of 2,200 contracts that we're analyzing for both of the two initiatives on this metadata enrichment project. As you can see, the majority of them are in English, Spanish, or French, of which our natural language processing tools do fairly well, but I'll talk a little bit more about that as we go on. The number of annotations, so that first finding clauses effort is about finding royalties clauses and stabilization clauses. What we have in this data set, and I'll go back a slide so you can just see it, this is again what the annotations look like. They look like highlighted areas of a contract that fit into a certain category. With these labeled clauses, we were able to train an algorithm, and on the next slide, I'll talk through the process that we're using to make sense of all this data and help it and use it to help our partners at NRGI become more efficient. So what we're seeing here, I'm going to first focus on the upper right side of the this slide. So taking the annotated contract, so we may have a contract from Colombia where the mineral in question is gold. It may be that it's marked up to show where the environmental reparations are talked about, where royalties are talked about, and what we're taking is that markup and training a random forest classification algorithm on those human annotated clauses using several different features of the text. Both the text, the stemmed words, remove stop words and punctuation, bigrams, trigrams, also using as features of those annotations part of speech tags, noun, verb, adjective, digit. Running sentiment analysis on those annotations, including the contract metadata, which may include the language and mineral in question, and then also including as a feature the average word length per clause. So all of that information goes into this random forest model, and we tune the model to minimize false negatives. And that was a request of our partner. They would much rather see that a clause was labeled but incorrectly rather than miss the fact that the clause may have been pertinent to some certain topic. So that was some tuning that was done before we actually handed off to our partners. We actually had a meeting with NRGI last week, and we went through some of the important features that are popping out. So when you're doing a royalties, when you're searching for royalties clauses, things like the stem word royalty, the stemmed word tax, all of those things show up as important features. And this was very valuable to us because there was actually a word missing from this list that our partners thought should show up as one of the top features, and that was the word percent. So we're going to go back armed with that information from our partners and look into the model and see if we can play with it a little bit and come up with some of the more expected features that for royalties and stabilization clauses. So then, now that we had a model developed, this random forest classification model, we divided the corpus. We actually had PDF documents of all these contracts, and what we needed to do was take the PDF document and split it into, well, first put it into a machine learning format, and then second, put it into, break it into certain clause length phrases that we could pass into the model and get these labels that we're showing down on the bottom right. So to do that, we did optical character recognition on the PDF documents. We parsed the documents into clauses, and then we passed all the clauses through the model and labeled with royalties, stabilization, and other tags. What we've come up with is this basically a table that has the contract ID, the clause, and the label that we applied to it, be that other, royalties, or stabilization. And what we'll be doing with that is having our partners at NRGI review these statements, these clauses, and let us know where the model is performing accurately and where it is not performing so accurately. A little bit more to say on the performance of the model. This is one of the tools that we're using to evaluate the performance of the model. And what this is it's called a confusion matrix. We've had a number of comments on how appropriate that name is, but let me take a second to explain what we're seeing here, and then talk about what this chart tells us. So the confusion matrix is a mapping of true labels to predicted labels. So we have the true label on the y-axis, the predicted label on the x-axis. And what we're saying is that, for example, in this box with the 3 here, we predicted the label of the clause to be other, but in reality, the clause was actually about royalties. And we know this because we break our data up into test and training by pieces, and we can run the model on known outcomes. So what we would ideally see in this confusion matrix is a strong high numbers on the diagonal and low numbers off the diagonal. What we're seeing is that we have, we're doing actually fairly decently with this. We have an overall accuracy of 94%. And I'll say that we actually had a higher accuracy that we let slip a little so that we could prioritize false positives over false negatives. By way of one more example, just so everybody's on the same page, what this 72 represents over here is that the model was predicted, this was a stabilization clause, and in 72 cases, it was actually an other clause. So that's a great example of a false positive that the model, for some reason, thinks it's about stabilization. We want eyes on the output to be able to say, here in these cases, this is probably what we're seeing happening. Then we can go back to the model and make some adjustments. So that's what this output here is about. Like I said, ideally we're going to see the largest numbers on the diagonal, and we're seeing that. So we're doing pretty good. So through this, using this confusion matrix as well as some of the other output from this model, we don't believe that major languages will be an issue, be that English, Spanish, or French. Arabic might be slightly more challenging. The NLTK libraries don't necessarily support some of those other languages. So given that most of our contracts are in English, Spanish, or French, we think we're doing pretty good. Like I said, we did take a small hit in accuracy so that we could minimize the false negatives. So minimizing the bottom left, the numbers on the bottom left, and maximizing the numbers on the upper right. We have a question. What do the 3 recall values represent? I'm pretty sure those are by label, but Jackie can jump in here. I think the accuracy on the predicting other is 94%, accuracy on predicting royalties is 96%, and accuracy on predicting recall on all of those is 93%.
Yes, that's correct, Erin. Recall is reported per label in order other royalties and stabilization, and the accuracy is the overall percentage of correctly predicted labels.
Thank you, Jackie. And then finally, like I said, the next phase of the work is to develop our final deliverables in addition to the prototype deliverables. So we have provided, Jackie actually just provided to our team this morning some information that they will be able to run through the labels and let us know where the model is getting it right or not getting it right, and any trends they see that would help us tease that out in the model. So I'm going to pause quickly here. There's a couple questions that I will address, and then I will go on to the next part of the metadata enrichment project. So someone asked, which language did we use? Also, which libraries did you use for working with French and Spanish data? I can answer the first part of that, and I'll hand off to Jackie to answer the second part of that. But the languages, I only put it English, Spanish, French here because they represent 2,100 out of the 2,200 contracts. Jackie, could you call out a couple of the other languages that we saw? I know there was Portuguese, there was...
Yeah, so we were able to use, so NLTK has really good support for English, Spanish, and French. So when we were doing stemming, you just have to specify, when you're doing OCR, you have to specify the language. When you're doing stemming, you have to specify the language. So there's definitely some level of input there. And, English, Spanish, and French are very well supported with most of the libraries. However, when we were doing some, like Arabic, for example, does not have very good support. So there were only a few contracts in Arabic, and they had to be discarded from the corpus.
Thank you, Jackie. Any other questions on the finding clauses component of the metadata enrichment project?
If you don't mind, I'd also like to point out that this 162 number represents a lot of incorrectly labeled data. So another side benefit of tuning the model for a high rate of recall is that helps you identify any falsely labeled clauses so that they can be fixed, and then you can retrain the model from there.
Great. So from here, I'll talk about the next metadata enrichment project. We really did 2 for 1 here. This is trying to compare contracts. So again, like I was saying, we have a corpus of contracts. We'd like to understand where are some of the contracts differing from the norm. And I'm using air quotes that you can't see right now, but the norm being the most typical of contracts. How do other contracts differ from that? So to do this project, we came up with again, we needed to do optical character recognition on the PDF documents and clean some of that output. Then we did Raven fingerprinting to hash the document into chunks, which are features of the full contract. So you can imagine that here we have 4 sample contracts, and I've hashed that into several different chunks that we will be able to say, this purple part is not common to other parts, but this teal part here seems to be in contract A, B, C, and D, so it's probably a fairly common part. But we want to say what are the parts that stand out. So to do that, we took these chunked contracts and said, let's take an entire contract and run an unsupervised learning algorithm and cluster the output so that we can see what we're dealing with. And so you can see from this contract A that it's pretty much at the center of a cluster, which indicates that it's most typical of all of these contracts in the cluster. Contract B is from that same cluster, so likely related in some way, but is more of an outlier. Contracts C and D are part of a different cluster, so they may pertain to a different country or a different resource. So we will take these documents and plot each of the documents and find the centroids and name those templates. So we said for this cluster specifically, we have A, which is very typical, and B, which is not so typical, which is an outlier and has some significant differences. So we'll then compare those two. This is the proposed approach that we will be taking. We'll compare the 2 documents, the template and the non-template, and find out what the differences are and be able to point to those differences. So for example, they both have this lime green section, they both have a teal section, they both have like a salmon section, but contract B has this orange section that is not part of contract A. So we want to be able to focus someone's attention there and say, what is it about this part of the contract that differs from the rest? We employed hierarchical network-based unsupervised learning to do this clustering. And then once we come up with this, we will be able, or once this model is run on the full corpus, we'll be able to provide these anomalous sections to our partners at NRGI and say, does it seem likely that the A is a template, first of all? And second of all, given that B is related but fairly different, how do these, are these sections that we're highlighting relevant to your analysis? So that'll be where we go from here. As I said, Jackie just sent out the email today to the team who will be working on doing the manual review of our analysis results. And once we get the feedback from that, we'll be able to tune the clustering algorithm and hand it off as a solution to find templates and find anomalous content. But just by quickly showing one other type of output that you'll get from some of this analysis, this is actually the dendrogram that represents the clustering action. So it's possible that the first level of clustering is based on language. That would make sense. The second cluster could potentially be based on resource or country. These are the kind of things that we'll need to explore as we proceed on the project to be able to say, is it true, and what level should we be looking at to be able to find the content we're looking for. So I will pause again for questions if anyone has on the metadata enrichment project, and after this we are going to be speaking about the mining irregular activity project. Alrighty, I will move on to the next section then. So for those of you new to these webinars, this is the Detecting Irregular Mining Activity project. And basically what we're doing is taking satellite imagery with some known locations of mines, and hopefully being able to say, these are where the mines are that we can find from satellite imagery. And then there's a further step that I'll talk about as we proceed as we proceed through this conversation. So like I said, we start with some known data sets. So this is actually coming from the International Peace and Information Service in Belgium. We have actual lat-long locations of 2,200 mines in Eastern Democratic Republic of Congo. These mines are not 100% accurate. In some cases, we've seen activity that may not show up in the mining data set. In some cases, we've seen labeled mine locations that don't have any evidence of mining. But this is the closest thing we have to a source of truth, and overall it's fairly accurate as a means of saying this is where the mining is taking place at the moment. I will note that these are artisanal and small mines, so we are assuming that the fingerprint of an artisanal or small mine is similar to the other types of mines we're trying to detect. Other data we have for this activity are the Landsat imagery. So we're looking at individual 100 by 100 pixel satellite images. One of the features that we're calculating for this data set is distance to water from each of these 100 by 100 pixel satellite images. There's a number of other features. We're using the data monthly since the satellite started taking photos. We're using all of the color bands, and then you can see over on the right-hand side, we have actual maps that are indicate where the mining site actually is. So I'll explain the process of finding what those mines look like compared to taking the leap from centroids to mining masks in the next slide. So the approach that we were planning on taking was actually to use concession polygons from Global Forest Watch. Global Forest Watch is an organization that has a number of polygon boundaries around where people are legally permitted to do mining. But for our training data, which is where we know there are mines, we actually found that those concessions were not a good approximation. The concession is the overall area where one could potentially do mining, but they don't necessarily mine that entire concession area. So we actually took a step back and said, using that IPIS, artisanal and small mines coordinates, let's actually hand enlarge the polygons. So there may be that there's a point somewhere in this I'm looking at the image on the top right, there may be a point in there that represents that this is a mine. We would actually manually draw this orange line around the mine and say, this is the area that's impacted, and this is what we call our mining area. So those boundaries were drawn for 250 mines. I think the team is actually beefing up that number in terms of number of labeled data they have. But the next task is once these perimeters are determined, to create a model to detect spatial and temporal mining activity using the labeled mines from Landsat and Sentinel imagery. And using any method possible, oh, there's a question coming up for you, Sina. I'll have you check that and I'll get to you in a sec. Then we want to, from here we would like to say, okay, here, based on satellite imagery, this is where we believe all the maps, all the mines to be. And here is where we are finding mines that are not part of that data set. So that's what step 3A is to identify mines that are not part of the artisanal and small mine data set, which indicate that we have found a mine that is not previously known. What we will do is then take that information and say, okay, we found a mine at location XYZ with certain polygon. We're partnering with Global Witness to validate that the new mines confirm that the model can detect new mines. The naive assumption is that the artisanal mine signature is the same as the industrial mine signature, so we hope to be finding artisanal and/or industrial mines. This approach that I've outlaid here in steps 1, 2, and 3 is actually very similar to something a professor at Stanford, Santiago Saavedra, has come up with. So this was the approach the team came up with, and only later found out that someone has done something very similar. So it was very vindicating in terms of what we think we can accomplish. Then, as you recall from the original slide on this project, what we really hope to be doing is trying to understand the conflict and environmental impact of these mines that are not part of known data sets. So we would, again, partner with Global Witness to determine if there's conflict and what type of environmental impact is occurring. And then finally use the validated image detection model to detect temporal activity and spatial boundary mines within Global Forest Watch concession boundaries. So that's to say there may be new mines that we uncover that are not part of the Global Forest Watch data set. There may be some that are part of the Global Forest Watch data set, and of those, are they temporally or spatially out of concession is the thing that we're really looking to understand. So DataKind is really providing the method of uncovering new mines. Our partners are the on-the-ground folks who are saying this is a mine or not, and here's what the impacts of those mines are. Whoops. So those are the two projects. I'm actually going to pause here. There was a question for Sina that I didn't address, but the question was, you take the images from Landsat, but where did the masks come from? Sina, can you help me on that one?
Yeah. So as I mentioned, as Erin mentioned, we hand draw the areas that we thought that there are mines around the center of the mine that we had. And so the masks are technically coming from the hand-drawn training data set that we created.
Thank you, Sina. So what have we learned so far from doing these two projects? I would say that on the whole, what we're learning is very similar to what we learned from other data, just doing data science in other industries. We could, by the example of the prioritizing for false positives, we may have been doing this on our own. We may have chosen that false negatives were more important, and we wanted to call those out. This is something that only our partner can tell us, and they can tell us why it's important and how it's important. So again, hearkening back to the last webinar where it really takes a village to do this data science together, our data scientists can optimize for what the variable in question, we just need to know what that is. The source of truth may not always be 100% accurate. We can't always wait for the perfect data. So in the case of the metadata enrichment projects, we were algorithmically determining what the most typical contract was and defining that as a template rather than relying on someone's having said, this is a template, now compare everything against this. In the irregular activity project, as Sina just described, he had to draw the polygons where there was a high level of certainty about mine boundaries. Again, if we were to wait for the mining data set that had that, we could be waiting longer than we need to. And where DataKind likes to play its hand is where we can make processes that are make processes more efficient. So we prefer less to advocate on top of some finding and more to increase efficiency of the people we're working with. So by being able to save the amount of time that we have with the metadata enrichment, being able to say, look here, rather than peruse this whole document and find what you're looking for. And in the irregular activity project, being able to say, here are where we think there are mines, I would go to these places first, rather than just do a broad perusal of the country. These are great examples of where DataKind likes to play. And then finally, we'll always have noisy data. This is manifesting as clouds blocking the visual spectrum on the ground for the satellite imagery. And as Jackie highlighted, in that confusion matrix, there were certain contracts that were mislabeled. Some algorithms are more suited to dealing with that type of import data than others. That was certainly something that we needed to consider as we were doing this modeling. So looks like we have another question. I'm gonna end the formal presentation here and ask people to submit their questions online, and we will try to get to those as time allows. So we have one question for the satellite imagery project. For model application, do you already have a plan of how to select the candidate regions where illegal mining could be happening? And I think the answer to this is we've chosen Eastern Democratic Republic of Congo, but let me keep reading. It seems most of the regions would actually be negative, no illegal mining happening, so the only one. Sina, did you see this question?
Yes, so it's a great question, actually. The idea is like, how are we gonna select the precision recall rate? And that's true that the minings are very rare within the areas. So even though, as you mentioned, 5%, as the question mentions, that if we get 5% false negative, we'll have, let's say, 50 false positive. Is that at the end of the day, the whole idea of the partnership with the group of witness will come out so well here that we're going to select many sites that we believe they have illegal mining. However, they might not have it. So we're narrowing down from 1,000 area that they have to go and look at to, let's say, even 10. And then within that 10, probably one would have the mining. Still, we're leveraging the investigation by a lot. So so I think that is true. As not, there's no way that we can get this to be very accurate, and we definitely gonna have a lot of false positive. But we'll be able to, with the partnership that we have, we would be able to go to those sites and check for those false positives.
Thank you, Sina.
Sure.
There was another question on, is there any experience with contracts made in Colombia or South America? I would say that for this one, actually the work of Santiago Saavedra at Stanford, and then he's associated with another university in Colombia as well. He did his study focused in Colombia. Ours, as I mentioned, is focused in Eastern Democratic Republic of Congo. So if you're interested, I'm not sure if you're interested, whoever asked the question, Saul, whether the contracts made in Colombia. We also did have, as part of our corpus, a number, for the metadata enrichment project, a number of contracts from Colombia, if that answers your question. And then Antonio asks, how are the partner companies going to use the metadata enrichment project output? Is the final objective to find dodgy contracts? Actually, this was something that we danced around with language a little bit as we were writing up the project briefs. The ultimate thing that our partners at NRGI are trying to assess is fairness of contracts. That's one of the things they're trying to assess. So being able to say, here's a section that didn't even exist in most contracts, and we're including it in this one. That may be something that will help people understand fairness. It may also be that there are trying to find where the royalties clause is. There may be multiple sections of royalties clauses, and that could be telling. So ultimately, the folks we're working with are assessing the contracts for fairness, but we, as data scientists, didn't want to go that full direction. We just wanted to point them in the right direction rather than assess it ourselves.
Yeah, I think transparency is the main goal here, and to allow anyone, even someone who's not a legal expert, to be able to parse the contracts themselves. Did we lose Aaron?
Oh my gosh, I was just on mute for a long time.
It's been a few minutes.
Alrighty, well, thank you for calling me out. Basically, what I was saying was thank you all so much for attending. I'm Erin at DataKind.org. If you have any questions that we weren't able to answer during this presentation, I'd be happy to answer them afterwards. We will also be sending out a link to this recording of this webinar, along with registration for the next webinar that will be happening in January. So if you all liked what you heard or have any other feedback, please don't hesitate to provide that. These webinars are intended to educate you guys. So whatever we can say that is however we can shape these to be most useful to you is what we want to do. So thank you all for attending. I apologize for that brief stint on mute, and we'll be in touch again soon.